Everyone, welcome back. So this time we're doing some problems from chapter 19. And chapter 19 is all about how temperature change and heat application are going to affect our materials. So we'll do some simple problems to start off. And the first one is simply asking us if we have 25 pound mass, and yes, I'm doing it in pound mass because I want to give you the evil units from the beginning. And this is going to be of a 1025 steel. Okay. So we have this, and it's initially at a temperature of 25 degrees Celsius. So T initial is equal to 25 degrees Celsius. And you're already hating me because I have these in mixed units. And it's asking us, what temperature would we have if we added 125 BTUs of heat? Okay, so we have these 25 pound mass right here, 25 pound mass. We're going to add in some heat. How much? 125 BTUs. And then that's going to give us the same thing, but at a different temperature. So 25 degrees Celsius to start, and we're at some mysterious temperature at the end. Okay. Now I'll give you one easy thing here. I'll just look at, that 25 degrees Celsius, that is 77 degrees Fahrenheit. If you don't know how to do that, it's not too hard. Just plug it in Google. I'm sorry, I had to say that. Okay. But seriously, it's not that hard to do the conversions. So don't worry about it too much. It's just 25 times 1.8 plus 32. That goes to from Celsius to Fahrenheit. And that right there is your temperature in Celsius. So long as that math works out properly. It does. Good. So with that being said, let's jump in here and do the rest of the problem. So if I'm adding in heat, there's an equation we can use for that. So delta Q, or I'm just going to use Q in this case, is equal to mCp delta T. So right off the bat, that's not that hard to do. We just have a little bit of rearrangement and we can get our answer. So delta T is going to be equal to Q over M times Cp. What makes this actually slightly difficult, is simply that your Cp, your specific heat at constant pressure, as a note, if you're dealing with a solid, your specific heat at constant pressure and volume are the same with the liquid. It's only when it's a gas they're different. This is given to you in different units. So if I actually go to the tables in your textbook, you'll find that the Cp for steel is going to be 486 joules. Not the best handwriting today. Let's try to fix it up a bit. Joules per kilogram Kelvin. Okay. Now I'm going to need to get this into English units, and so I'm actually going to give you the conversion. I'm going to do this in the future. In the future, I'll just give it to you in the right units. But I do want to show you this at least once. So Cp is going to be equal to 486 joules per kilogram Kelvin. Okay, and I'll give you a really wonderful conversion here. 1 joule per kilogram Kelvin is equal to 2.39 times 10 to the negative fourth BTUs per pound mass degree Fahrenheit. Okay, if I plug that in, what do I get? I get 0.116 BTUs per pound mass degree Fahrenheit. At this point, I can just plug everything in. So delta T is going to be equal to Q, which is 125 BTUs, over my specific heat, which I now have, which is 0.116 BTUs per pound mass degree Fahrenheit, and then multiplying that by a temperature change, which is going to be, by the mass, which is 25 pound mass. Let's check our units, make sure everything works out fine. Pound mass cancels, BTUs cancels, I'm only left with degrees Fahrenheit. And so I get a temperature change of 43.1 degrees Fahrenheit. And so what is my final temperature? The final temperature is simply going to be equal to my initial temperature plus the change in temperature. So it'll be equal to that 77 degrees Fahrenheit plus the 43.1 change, which gives me, let's see here, about 120.1 degrees Fahrenheit. And there we go. That's our final temperature. This is our change in temperature. And we have our answer. So that's it for this time. A unit conversion, which hopefully will help you for your problems if you do have to do the conversions. And a pretty simple problem of seeing how heat addition leads to change in temperature. Thanks for listening. I'll see you all next time. Bye-bye.